Hello students, good morning. Today we have to discuss about the new concept, that is the new article. The name of that article is uses of dimensions. Means what are the use of the dimensions? Up to this we calculate already the dimensions of different physical quantities. It may be fundamental or it may be derived. Now in this article we have to use that dimensions in the particular equations. So what is the use of these dimensions? So this article is very interesting. This concept also is very interesting. So see uses of dimension. So uses of dimension is to measure correctness, of a given physical quantity, of a given physical equation. Suppose any equation, if it is given to us and if we want to calculate its correctness, then how we can calculate? So suppose kinematical first equation is given, v is equal to u plus at. So this is the first equation and we have to measure its correctness. What? So for that purpose, how we can measure its correctness? So see here how we can measure its correctness. So first of all, write down all the physical quantities which contains in this equation. So V stands for what? Here V stands for velocity, that is final velocity. U stands for its initial velocity. A acceleration and T, that is time. Now see how the dimensions can use in this equation. So you have to put all the dimensions of the given physical quantities. So in this equation two sides are there, one is right, another is left. So left side is equal to right side. At that time that given equation is correct if the condition is left hand side is exactly equal to right hand side. Now left hand side is v is equal to, right hand side is u plus at. So v is equal to u plus at. So velocity, the dimension of velocity is L1 t minus 1. Then dimension of v, that is velocity L1 t minus 1, dimension of u, that is initial velocity. So same dimension we can use, that is L1 t minus 1. A acceleration, so accelerations are dimension L1 t minus 2 and time means t1. So firstly you have to write all the dimensions of a given physical quantities. After that put all the dimensions in that equation. Suppose this is equation 1 which is given to us, that is v is equal to u plus at. Now substitute all the values in this equation. What is the dimension of v? L1 t minus 1, that is the dimension of v, is equal to, the dimension of u is L1 t minus 1 plus acceleration Dimension of acceleration is L1 t minus 2 a into t multiplied by t is t1. So after putting all the dimensions in that equations, now we can easily calculate it. So left hand side will be L1 t minus 1 is equal to L1 t minus 1 plus L1 t minus 2 multiplied by t plus 1 minus 2 plus 1, it becomes minus 1. So the addition of these two, L1 t minus 1 plus L1 t minus 1. So here we are considering 1. Here also we are considering 1. So 1 plus 1, it becomes 2. So the addition of these two is L1 t minus 1 is exactly equal to 1 plus 1 to L1 t minus 1. So this 2 stands for integer, that is the number. So it has no dimension. So it is dimensionless quantity. So where 2 is a dimensionless quantity, therefore right hand side and left hand side, therefore left hand side L1 t minus 1 is exactly equal to right hand side L1 t minus 1. So therefore we can conclude that left hand side LHS is exactly equal to RHS. So if this condition is satisfied, then and then only we can say that the given equation, that is V is equal to U plus AT, it is dimensionally correct. Okay, so uses of dimensions means what? Using the dimensions we can calculate the given equation is correct or not. So using these uses of dimension, we can prove that LHS is exactly equal to RHS. It means that this given equation which is correct. Okay. Now similarly we can consider another equations. So this is the first equation of kinematics. So using second equations also you can prove that uses of dimension. How we can prove that? Suppose second equation, kinematical second equation, kinematical second equation. What is the second equation? S is equal to ut plus half at square. So what we have to do is, we have to do here, put all the dimensions in this equation. So this is kinematical second equations. So we have to check it is correct or not. So if LHS is equal to RHS, then and then only the given equation will be correct. So let us find this equation is correct or not. So you must know the parameters which are given to these equations, that is S stands for what? Where S stands for displacement, U stands for initial velocity, T stands for what? Time, E stands for acceleration. So these are the parameters which are given, and this is the second kinematical equation. We have to prove it. Okay. So now we start to prove the second kinematical equation. So left hand side must be equal to right hand side. LHS is exactly equal to RHS. So left hand side there is displacement S is equal to right hand side ut plus 1 by 2 at square. So put all the dimensions of this given quantity. So for displacement we know. So dimension of S is equal to L1, because displacement means what? It is a length. U initial velocity, we know the initial velocity L1 t minus 1. Then small t, it is for time. Acceleration, so for acceleration is equal to L1 t minus 1, t minus 2, then time for t1. So you have to put all these given dimensions in these equations. We have to put this in this given equation. So therefore S is equal to ut plus half at square. U, what is U? That is L1 t minus 1 into t. What is t? It is t1 plus half a. What is a? Acceleration L1 t minus 2, then into t square. T square, that is t1 bracket square. See here 1 by 2. It is a number, it is an integer, so it is dimensionless. It has no dimension. No dimension. So we are not considering that quantity is dimension. So it becomes, so S, that is L1. It is L1 T1 into T1. So minus T1 plus T1, it becomes 0. So L1 T0 is there, plus L1 T minus 2 square of T1, it is T plus 2. So minus 2 plus 2, it becomes 0. Therefore L1 is exactly equal to L1 T0 plus L1 minus 2 plus 2 T0. Therefore L1 is equal to L1 plus L1 2L1. That is 2 stands for what again? dimensionless. Therefore, LHS is exactly equal to RHS. If LHS is exactly equal to RHS, then and then only the given equation will be correct. Okay. So this is the proof of second kinematical equations, that is S is equal to ut plus half at square. Okay, thank you.